let's move on to do the final two questions on this review sheet. Suppose that you've solved a problem and it has an exact answer of x equals 0.1265. So let's write down this exact value of x in scientific notation. So we know in scientific notation we're going to seek the first non-zero number. Well, this is a 0, so let's ignore it. Here we go. That 1 is the first non-zero number, and so that's where our new decimal point is going to go, 1.265, because we need this number a in front to be between 1 and 10. So that 0 is just not appropriate. 1.265, and we're multiplying it by 10 to the power of, and let's see, we only moved our decimal point one place. But because the number that we're expressing is a very small decimal number, it must be a negative 1. Part B. State the value of x given correct to two significant figures. Let's just come back to the original value of x because it's a little bit easier to work with a number written in that standard form. Round it to two significant figures. So, just like scientific notation, the same principle that we're going to count through the number until we reach our first non-zero number. It is the first non-zero number that is significant. And so the next number will be a significant figure, and look, we've already got our two significant figures, and so this is our cutoff. The number to the right side of the cutoff is larger than 5, which means that the 2 is going to roll up to a 3, and then everything afterwards becomes zeros. And I don't need to write these zeros because I've already got two significant figures, and writing the zeros afterwards would not change my understanding of the magnitude of the number. And now we need to calculate the percentage error if x is given correct to two significant figures. You might remember that percent error is given as the absolute, well, it doesn't say the absolute percent error, does it? So maybe I shouldn't worry about the absolute symbol, which could mean I end up with a negative percent error. If it said an absolute percentage error, in that case you'd need to put in the absolute value sign that you'll see in your IB formula booklet when you're taking the quiz, and you got to make sure that you keep only the positive value of the difference. So we've got the approximate value minus the exact value divided by the exact value, and then we need to multiply by 100% in order to convert it back into a percentage. And so let's do this substitution. So our approximate value, it was 0.13. This was our rounded amount, its approximation. So 0.13. And let's now subtract the exact value of x, which is 0.1265. And then we'll divide this by the exact value, which is 0.1265, and multiply by 100%. So the calculator will help me out. 0.13 minus 0.1265. And we'll take this amount and divide it by 0.1265. You could have done all of this in one step if you wanted, but it would have been very important that if you did this in all one step, you would have had to ensure that in your calculator you've included parentheses around that subtraction, so we understand that it's the entire amount, that entire difference, which is being divided by the denominator. And now we'll multiply by 100 in order to convert it into something that I can use for a percent symbol, and I get 2.76, and it keeps going, but so I've got 2.7667 and so on percent, right? Because we know we've multiplied by 100 to change it into a percent, but we're told to round to two significant figures. So let's count through. And our first non-zero digit is a 2. So that's our first significant figure. The one that follows must be the second. That means that's the cutoff. And the number after the cutoff is bigger than 5. Yes, bigger than 5. And so the 7 will round up to a 2.8%. Let's have a look at the mark scheme and see how we did. So number 5. So 1 mark for the 1.265 and 1 mark for times 10 to the negative 1. And it says that it has to be an exact answer. So if you had rounded to 3 significant figures, you would not have gotten the first point. Part B is where we need to round to, I think it asked 2 significant figures, didn't it? Or maybe it asked 2 decimal places, I can't remember. But either way, there's our answer. And part C, you see that we took our approximate value, subtracted the exact value, divided also by the exact, and then multiplied by 100%. And, oh, this isn't right. No, this isn't right. The question said to round to 2 significant figures, didn't it? Yeah, the answer here is wrong. And I imagine that the IB, when they sent out this mark scheme to the examiners the year that this exam was written, they probably added some kind of addendum, or there was an emergency email to all of the examiners saying, obviously there's an error in the mark scheme. Maybe the question was supposed to be correct to 3 significant figures, and if it was correct to 3 significant figures, I would agree with the mark scheme's answer of 2.77. So I guess we'll never know whether this was a misprint in the exam, or whether it was an error in the mark scheme. But certainly our answer to 2 significant figures should be 2.8%. And so you'll see that you get a mark for actually showing the substitution of the numbers into the formula. This is something I think happened in a previous question too. There was a mark assigned for showing the substitution of the numbers into a formula. So I know that you might be tempted to go straight to your calculator, because you can do that substitution mentally without actually having to write it on paper. But what if you made a silly, careless mistake? Write down your substitution in paper first, so that if you make a mistake with the calculator entry and end up with a wrong answer, you can still get that method mark for having demonstrated the substitution of the numbers. And then you'll see that in order to get the second... Oh, and if you're wondering, why is it an M1 and an A1? It's an M1 for knowing to use the percent error formula and for doing the substitution, and A1 for substituting the correct numbers into the correct places. And the answer has to be a percentage in order to get this final mark credit. 2.8% it should be. And our last question in this review is number 6. So we need to calculate 77.2 cubed. Oh, that's not true, sorry. We need to multiply. Oh darn, I've made a mess of it. Let's just clear the whole entry. Start again. 77.2 times 3 cubed, so 3 to the power of 3. And if you've got the new operating system, you will need to press the right cursor key in order to get out of the exponent. And then we're going to divide by, and this is where the trap lies of this problem. We need to divide by the entire quantity, 3.60 times 2 squared. If I only wrote down divided by 3.60, the calculator would assume that this is the only thing I'm actually dividing by. And so then it will calculate internally that answer, and it will take that answer and multiply the entire thing by 2 squared. But this 2 squared is only applying in the denominator. So when you're dealing with fractions that have got complicated parts in the top or in the bottom, you're usually wisest to have them in parentheses. And so I'll show you how we can go back to the beginning, and I could insert some parentheses around the top just to make sure that nothing strange goes wrong. So if I press second delete, that goes to the insert option. You see that the cursor has now changed the manner in which it's flashing, and I can put in a parentheses sign. But as soon as I scroll over, it goes back to its regular regular cursor, and so we're going to need to again go to the insert cursor if we want to put in the right parentheses. As soon as I scrolled over, it's again the regular cursor, so insert There we go. And now I can finish my denominator with confidence that I'm not going to end up with a mistake. So times 2 squared. Close the parentheses, and our answer is 144.75. Part B. We need to express our answer in scientific notation. So scientific notation, we know that the decimal point comes immediately after the first non-zero number. And we had to multiply by 10 to the power of, well, let's see, I moved the decimal point twice in order to get scientific notation. And because our number that we're dealing with is relatively large, it's a positive 2 in the exponent. Part C. Juan estimates the length of a carpet to be 12 meters and the width to be 8 meters. He then estimates the area of the carpet. So how do you find the area of a rectangular carpet? Well, we know that area is length times width, isn't it? And so that's going to be 12 meters times 8 meters. And on the calculator, we are told that 12 times 8 is 96. And so we have 96. And it would be good to include the units. Now, if a length is in meters and a width is in meters, what is the area in? Hope you said meters squared. And the last question is part D. When the carpet is accurately measured, it is found to have an area of only 90 square meters. Calculate the percentage error. So again, it didn't ask for the absolute percentage error, which is what you're given in the formula package. I don't think you would have marks deducted if you used the formula package, if you used its absolute value, percentage error, sorry. But I think that because it doesn't mention it explicitly here, we won't bother with the percent error. And we know that we have our approximate value minus the exact value, all divided by the exact value times 100%. So let's write down the substitution, because if I make a mistake in the calculation, it would still guarantee me a mark. The approximate value, this was Juan's estimation, right? This ends up being an approximate, not an exact value, so that's the VA. And then we'll subtract the exact value of 90, where we found that when it's accurately measured, that's our exact, divided by exact times 100%. And now I'll come over to the calculator. You remember I said that when you've got like a complicated numerator, something like that, then we should really put it into parentheses when we're putting it into the calculator. So 96 minus 90 in the parentheses, and we'll take that quantity and we'll divide it by 90, and then we'll multiply by 100 in order to convert our final answer into percentage. And we get 6.66666667. 66666. Okay, I mean it goes on forever, percent, doesn't it? So you can interpret this in a couple of ways. I guess you could think of it as 6.6 repeating, and if you know that notation, I imagine IB would probably accept it. But we know that there's something bigger in play here, that when the question does not specify how many significant figures or decimal places to round to, we always need to either give the number as an exact value. Well, we could never give this number as an exact value unless we did use that special notation for 6.6 repeating. And so that bar over the 6 shows it's repeating. But I imagine, sorry, that's going to be exactly equal to, isn't it? But I imagine that IB's probably expecting you to round to 3 significant figures, 6.67, because after 3 significant figures, the 6 is higher than 5 and raises the last digit to a 7. Don't forget your percentage sign. So we'll quickly look at the mark scheme before my time runs out. Part A, 144.75. It's interesting that they accepted a 3 significant figure answer. Part B, scientific notation, 1 point for the beginning, 1 point for the times 10 to the negative 2. 1 point for the area of 96 meters squared, and you should have the units in there. And part I, percent error, is going to be the difference between the approximate and exact divided by exact times 100. I'm surprised they didn't write the percent there, but you notice that they did in the answer. And this is interesting, they wrote the answer as an exact fraction by not using the calculator. They just cancelled between the 100 and the 90 and the 6, and then they expressed it also in an approximate value to 3 significant figures with a percent